Hello, welcome to 3.6 video. 3.6 deals with word problems, and systems of equations. So, hopefully, if you're starting with 3.6 homework assignment, then you finished all the previous ones in chapter 3. And so you are pretty proficient with solving systems of equations using either substitution method or elimination method. Okay, so what we're going to do here in 3.6 and 3.7 is focus on setting up the problem and into a system. And we won't be solving the system because I'm assuming that you guys are proficient with that. If you need help with solving, then you need to go back and look at the videos for 3.2 and 3.3. Okay. Again, if you need closed captioning, click on the bottom down below on the right. There you should see a button with CC on it. Okay, so let's take a look here in this example. So the setup cost of a machine that mills brass plates, so it makes brass plates, is $750. Okay, so the setup cost is $750. One thing about word problems, so the thing is, there isn't one way to do these. So it's really hard to teach word problems to students because I can show you this one, but then the next one is done differently. But just keep in mind that when you're doing these word problems in 3.6 and 3.7, it needs to relate to systems of equations. So you should be setting up a system of either 2 equations or 3 equations, and then you're solving that system. So just keep that in mind. You need to set up a system of equations. Okay, so here, setup cost of a machine. Okay, setup cost of a machine is $750. Okay, so we know the setup cost is $750. After setup, it costs 25 cents to mill each plate. Okay, so 25 cents to mill each plate. Okay, so $750 and then 25 cents for each plate. Management is considering the purchase of a larger machine that can produce a plate at a cost of 20 cents. Okay. If the setup cost of the larger machine is $1,200, how many plates would the company have to produce to make the purchase worthwhile? Okay. So when you set up, so we know we're going to need 2 equations here. Okay. 3.6 deals with systems of 2 equations. Okay. So let's go ahead and do this. All right. So you can use whatever variables you want. Sometimes just using X or Y is fine. Whatever variables you want to represent the unknown quantities here. So here we're talking about the costs, okay? The cost with the current machine and the cost if they use the larger machine, okay? So we know the cost with the current machine is $750 plus 25 cents per plate, right? Okay, so I'm going to define my variables. So I'm going to let C represent the cost, okay? And I'm going to let P represent the number of plates. Okay, and I need to come up with 2 equations. Well, I'm dealing with 2 different machines here, so I'm dealing with 2 different costs for the company. Okay, so the first cost is $750. That's the setup, plus 25 cents per plate. So 0.25 times P. Okay. So that's my first equation. Okay, and this here represents the cost for the first machine, the current machine that they have. If they use the larger machine, it's 1,200 for the setup. So the cost is going to be 1,200 for the setup plus 20 cents for every plate that they make. Okay, so here we have our system, and then hopefully you're able to solve this by substitution method or elimination method, whichever one you prefer. Okay. And here, since it's fine if you work with decimals, you can use a scientific calculator. That's fine. Okay. If you want to clear your decimals the way we clear fractions, you could multiply everything by 100 to move this over twice. Okay. That's one way to do it. Or you can just deal with the decimals. Okay. But in any case, this is how you would set up this first problem here. Okay. You're trying to come up with two equations. Okay. All right. Let's take a look at the second example. Okay. So the Spirit of America, one of the Goodyear blimps, flew 175 miles. So it flew 175 miles in 5 hours with the wind. Okay. So it flew 175 miles in 5 hours with the wind. Okay. The return trip took 7 hours flying against the wind. Find the speed of the blimp in still air and the speed of the wind. If any of you guys do any flying, if you fly fixed wing or helicopters, then you could really imagine what this is like, especially in a helicopter. One time we were flying and it was super windy, and so we were trying to figure out, well, how strong is this wind? So we went ahead and hovered, and we were pushing 30 knots. So it was reading that we were going 30 knots, but we were just not moving. So it was a 30 knot wind that we were facing. Okay, so here the Spirit of America flew 175 miles in 5 hours with the wind, and then 175 miles took 7 hours against the wind. Find the speed of the blimp in still air and the speed of the wind. Okay, so here, if you're not sure how to define your variables, like the previous example, it was a little straightforward. Here, they're asking you to find the speed of the blimp and the speed of the wind. Whenever they ask you for two things like that, those will most likely be your variables. Okay, so let's go ahead and let B equal the speed of the blimp, and let W equal the speed of the wind. Okay. And then also note, maybe you remember this distance formula. Distance equals rate, that's your speed, times time. Okay. Distance equals rate times time. Okay. So let's figure out that first one here. 175 miles, that's our distance. Our rate, we don't know because they're saying find the speed. So we don't know it. Times time. Okay, so here, let me just. So your formula is distance equals rate times time. Okay. All right, so distance, 175 miles, equals your rate. We don't know the rate, but we know that whatever the rate was, it is the speed of the blimp plus the speed of the wind because they're going with the wind. Okay, so it's going to be whatever the speed of the blimp is plus the wind that's pushing it. Okay, so that's our rate times time. And it says here it took 5 hours. Okay. And then the return trip, well, it's a return trip, so it's the same distance. So it's 175. And this time it's the speed of the blimp, but now it's going against the wind. So minus whatever the speed is for the wind. Okay. And it took 7 hours. So again, distance equals rate, your speed, times time, 5 hours, 7 hours. Okay. And then you can use your distributive property here, but this here would be your system that you would need to solve. Okay. So again, they take some getting used to, but again, so long as you keep in the back of your mind that you're trying to set up a system and try to identify what your two variables are, you should be able to come up with the equations. Okay. Again, if you have questions, make sure you message me through the Remind app. Okay, so let's take a look at this one, example 3. The perimeter of a rectangular field, so the perimeter, that's the distance around the rectangle. So the perimeter of a rectangular field is surrounded by 72 meters of fencing. Okay, so here, this would actually be a good time to draw. Whenever you're given like geometric clues, rectangular field, okay? If the field is partitioned into 2 parts, as shown, okay, it didn't allow me to copy and paste the picture. Okay, a total of 88 meters of fencing is required. Find the dimensions of the field. Okay, so far right now we know the perimeter of this rectangular field is surrounded by 72 meters of fencing. So if you remember, so we'll call this length, and these two are the same. And this here is width, and these two are the same. And we know that perimeter, if we add up all the sides, right? So we have 2L plus 2W. Okay, so we know that 2L plus 2W equals 72. Okay, so that's our first equation. And then it's partitioned into 2 parts like this. Okay, so now here, the length of this fencing is the same as this and this. So this middle piece is now sublength W. Okay, and it says that if the field is partitioned into 2 parts as shown, a total of 88 meters of fencing is required. Okay, so then we have 2L plus 3W. So 2L plus 3W equals 88. Okay, and there is your system of equations. Okay, find the dimensions of the field. So find the length and the width. Okay. Here I would probably use elimination method and I would eliminate the L's. Okay, let's have a look at this one. Example 4. To protect against a major loss, a financial analyst suggested the following plan for a client who has $50,000 to invest for 1 year. $50,000 to invest. Wouldn't that be nice? Okay. 1, Alco Development has a high yield, 12% per year. A certificate of deposit, a CD, has a low yield, 4.5% annual interest. Okay. 12% interest, 4.5% interest. Okay. If the client puts some money in each and wants to earn $3,600 in interest, how much should be invested at each rate? Okay, so it's kind of like the person doesn't want to risk it all and put it here, but then they also don't want to put it here and have that slow growth. Okay, so they're willing to take some risk and invest over here. Okay, or I suppose they could just go on Reddit, right? And pull a GameStop. Okay, anyway, let's not go there. All right, so let's go ahead and so the question is, how much should be invested at each? Okay, so let's let X equal the amount in Alco, invested in Alco, and let's let Y represent the amount invested in the CD. Okay? All right, so then you want to try to see if you have any totals. We have a total here, 50,000. That's the total amount of money. So then there's our first equation. This amount and this amount should equal 50,000. So X plus Y equals 50,000. Okay. And we have this other total here, total amount of interest. Okay. So let's see. If we want to figure out the amount of interest earned, okay, so here, X is in ALCO, so we get 12%, 12% of this amount, so 0.12 X, and then here we get 4.5% of this amount, so 0.045 Y, and we want that, so this is the interest collected in ALCO, and this will be the interest that we collect in the CD. And we want this total amount of interest to be 3,600. Okay, so here is your system. And again, you can keep your decimals and just use your scientific calculator to work with this, or you can clear your decimals. We need to go 3 decimal places, so you would need to multiply by 1,000. Multiply by 1,000, this will move 3 places. This will move 3 places. And this one will move 3 places. Okay? So that's how you can deal with the decimals. You can keep them, use a calculator when you're solving the system, or you can clear them and still use a calculator. Okay? All right. Let's take a look at the next one. Example number 5. A manufacturer builds racing bikes and mountain bikes with per unit cost shown in the table. The company has budgeted $26,150 for materials. So there's only a certain amount for materials and $31,800 for labor. Okay, how many bicycles of each type can be built? Okay, so here, racing bikes, it costs $110 for materials and $120 for labor. Mountain bikes, $140 for cost of materials and $180 for labor. Okay. I'm just looking at this. If anyone has bought a mountain bike recently, someone's making profit. All right. There aren't no $300, $400 mountain bikes anymore. Okay, so let's take a look here. $26,150 for materials, $31,800 for labor. How many of each type? Well, so how many of each type? That's how you're going to define your X and Y. So let's do that. Let X, let X represent the number of racing bikes. Hold on, my neighbor's knocking on the door.
Jet! Can you open the door? I'm in the middle of a lecture video. Chia's here.
Sorry. So X equals number of racing bikes. Y equals number of mountain bikes. Okay, so we have that defined. Okay, so now the cost of materials, it's $110 for each racing bike. Okay, so and it's $140 for each of these, and they have a total of $26,150 to spend. So here's our first equation. So 110 times X plus 140 times Y equals 26,150. Okay, this is how we would figure out the total cost for materials. Okay, so we want the total cost for materials to equal this, and at the same time, we want the cost of labor, which is 120 times X plus 180 times Y, to equal, how much did they allocate? 31,800. Okay, so we want both of these things to be true. So the question is, okay, well, when does that happen? When we have how many of racing bikes and how many mountain bikes? And there's your system. Again, you can use substitution or elimination to solve that. Okay, example number 6. In 2010, there were an estimated 172 million dogs and cats owned in the United States. 172 million dogs and cats owned in the United States. If the number of dogs was 16 million less than the number of cats, how many dogs and how many cats were owned in the US that year? Okay, so here again, they're asking you to find how many dogs and how many cats were owned. So there we go. We can define our variables. So let's let X equal the number of dogs, and let's let Y equal the number of cats. Okay, so what do we know about them? We know that 172 million dogs and cats were owned. So then X plus Y equals 172 million. Okay. What else do we know? The number of dogs, that's X, was 16 million less than the number of cats. So the number of dogs was equal to 16 million less than the number of cats. So the number of cats, make sure you write these in the correct order. It's the number of cats minus 16 million. Okay, so make sure you have this in the correct order. Number of cats, but 16 less than that. Okay, so here you have your system of equations. And here, since this one is solved for X, I would use substitution method to solve this one. Okay. All right. And so that is it with these. Again, they can vary slightly to quite a bit, the word problems. So I tried to do 6 with some variation there, so you have an idea. But again, keep in mind that you're trying to solve a system. So you're going to try to use 2 variables, and you're trying to come up with 2 equations. Okay. And trying to figure out what you're going to let your variables represent, that's always a good place to begin. Okay. And if you're not sure what to let them represent, always look at the question. How many dogs and how many cats? Well, that's what you're going to be solving for. So let's let X and Y represent those things. Okay. All right. So that is it for 3.6. 3.7 is going to be done the same way. Again, if you have any questions, make sure you email me.